So this presentation, let's discuss the series other functions, like how to filter the values in a series, how to perform operations and mathematical functions in series, how to evaluate values within the series, and the concept of NaN values. So let's first discuss about filtering. Now filtering of values is also present in NumPy, and since Pandas is built over NumPy, the same concept is extended even here. So suppose we have already defined a series called as S. So let's go to the Jupyter notebook. So I have created here a series. So how do you create a series? pd.series, call the constructor and give the value. Suppose these are the values which I've given into the series, and this is the S3, the series which has been constructed. Now I can do filtering of values here. Suppose I just want to pick values which are greater than 20, let's say, within this series. Then you just have to type S3 and within the square bracket specify the condition or the filtering condition. So I just want to say S3 greater than 20. So then a series will be displayed here, which would consist of only values greater than 20. So in this case, the value with the index 1 and the third index would be printed. So when the series is printed, again in the same format, both the index as well as the value will be printed. So this is called as filtering concept. Now coming to the next one, we can perform operations and different kinds of operations on series as well as mathematical functions on it. So these are the different mathematical operations that we can do. We can do addition with scalar values. So I can have a series, let's say S, upon which I can add a scalar value. So when I say +2, so number 2 would be added to each and every element in the series. So when I say -2, it will subtract 2 from each element in the series. When I say *2, it will multiply each element by 2, divide by 2, divides each element in the series by 2. And suppose you want to do exponential, then S double asterisk 2. So it will raise each element in the series to the power of 2. S modulus 2, where you get the remainder after dividing by 2. In this case, what is the remainder that would be displayed? And when you give floor division, in the sense double slash, it will divide and it floors the quotient. Let's try 2 examples regarding this. So I have already created a series here S3, and these are the values within the series. Now upon this, when I say divide by 2, this is scalar division. So every element in the series is now divided by 2. So when I say logarithmic operation, I can also do NumPy operation on the series. So if I say np.log of S3, it is going to perform logarithmic operation on every element in the series. So let's try the floor division. Let's say, so if I say S3 floor division, that is double slash. So what happens here is, see, the initial value of S3 is, in the first one is 11. So when I say 11 by 2, it will do round off. When I say floor division, what happens, it is actually rounding off. Instead of giving the value as 5.5, see, this is S3 by 2 and this is S3 floor division by 2. So you can make out the difference. It is just rounding off. It is removing the decimal value. So instead of giving 5.5 for the first case, it gives 5. For the third case, instead of giving 1.5, it gives 1. So that is a floor division. So you can do any arithmetic operation with the scalar value on the series. You can also do operations between the series. So let's say I have created 2 series here, S1 and S2. So I can perform operation between these two. I can add these 2 series, I can subtract these 2 series, I can multiply them as well as I can divide them. So let's take a case of this. See here S1, I have created a series like this and these are the values. I have created another series S2 with these values. So you can observe here that S1 has 5 values of 5 indexes, but S2 has actually 4. So they need not. So how does this operation then happen between the series? The concept is, when operations or arithmetic operations happens between the 2 series, Pandas will automatically align the data by index labels. That means it's going to do operations between the values which have the same index. Now suppose an index does not exist with a value, then it will generate a NaN. So in this case you can see that S1 index A is having a value 1 and here index A is having a value 8. So the resultant, if I do a plus operation between these two, then at in the new series created at index A, it will have the value 9. Similarly, for the index B, the operation is done between respective B indexes of S1 and S2. So here B is 2 and here B is 6. So the addition would be 8. So at B you are having 8. But when you see at D you have a value 4 in the series S1 and here you do not have any D in S2. So automatically NaN, that is number, since the number is not existing, NaN is added. And since there is no, in S2 we do not have D and E, that is why you can see at D, E we have a NaN value. So basically what happens is when you're doing operations between the series, it aligns the data by index labels, and suppose a value does not exist or a label does not exist, NaN would be added in the resultant value. Now coming to the other kinds of evaluations which are possible on series are, you can construct a series with duplicate values, and upon that you can use some functions. So let's say I have created a series like this and there are some duplicate values here. I have 1 2 times, I have 2 2 times, right? So if I use a unique function upon this series, then unique function it will only find the unique values in the series. So it's going to give the result of only the unique values. I can also use a function called as value underscore counts, where even here it will return the unique values as well as it will give a count of all the values within a series. So let's see this on the Jupyter notebook. See, I have created here a series like this. You can see that there are duplicate values. I have 1 2 times and I have 2 2 times. I have also given an index here for each value. So this is how the series is created. See, I have labels which are repetitive as well, okay, but here the values are important, okay. So when I call the unique function upon this, the name of the series I have called it as SERD. So upon this, when I call the unique function, what happens is it will find only the unique values in the series. It will exclude the duplicates, okay. So see here, what are the unique values in the series? 1, 0, 2, 3. The duplicates, this and this, are left out. So that's unique function is used to find only unique values in the series. You can see here 1, 0, 2. These two are duplicates, so that's why this is left out, and 3. So only unique values of the series will be printed on the screen. Coming to the next function, value counts. What value counts function will do is it will return the unique values as well as it will tell us the occurrences of all values in the series, how many times these values are there, so that it is going to say. So for example here 2 is printed 2 times, 1 is printed 2 times, as well as 3, the value 3 exists only once, the value 0 is only once. So basically this right column is telling the occurrences, and these are the left column are actually the values, because you only have 0, 1, 2, 3. So how many times you have 0, how many times you have 1, how many times you have 2 and 3, and it is giving only unique values. See, 2 will not be printed 2 times. 1 is not printed 2 times. That's why it is also returning unique values. It will not repeat, but it will give the occurrence. Now there is one more function called as isin function. So isin, as the word itself says, is in, it's going to check is it present. So isin function, it will take arguments as some values and it will check is this present, isin. If it is present, it will return a boolean value true. If that value is not present, it will give a boolean value false. In SCRD, what are the values we have? In SCRD series, we have 1, 0, 2, 1, 2, 3. So we are actually having only 0, 1, 2, 3 values. So in the arguments, I have given 0, 3. See, at the first label, what is there? White. What is the value here? 1. So it returns a false because it does not contain 0, 3. The next in the next row, white is what? Again it is 0. Yes, 0 is present, right? So wait, I'll just try to add a surd here again, so that it's you can easily see this in one shot. So this is our series. So this is our series, right? So what is it actually checking? See, this is our series and these are the values. So isin function, what it is doing, for every label it is checking whether these two values, if either, because it is comma, if either one is there also, it will return a boolean value true. If one of them is absent, if both are absent, then it will return a false. See, white is 1, so it is not 0 3, so it returns a false here. Second row, white is 0, yes, so it gives a true. Blue, it gives a false. Again here it gives a false. Again for green it gives a false. For yellow it gives a true. So the name itself says is in. It's just checking the presence or absence. If it is present, it gives a true. If it is not present, it gives a false. Similarly, you have one more function called as a very important concept that we have in series is NaN concept. So NaN stands for not a number. So now this is used, you can come across this concept many times, especially this is very useful when you are dealing with large data. Whenever you are using some real-time data ranging up to 50k, 50,000 rows or even more than that, you will see that there are a lot of empty fields or empty values which are not there, or values are not generated. So in such cases, NaN value will be replaced by the pandas automatically. Now that can also be a problem because data analysis becomes very difficult, right? These data are can give some kind of missing data, can also be a problem. Having NaN also can be a problem during our analysis or interpretation of the results that we obtain. But there are reasons for using this or creating these NaN values, because after some mathematical calculations it's possible that logarithms you might be trying to calculate logarithm over negative value, or it's possible that when you're doing some calculations you might be creating some kind of exceptions. So you do not really want your program to crash unexpectedly, right, when such things happens, right? When you're trying to divide by 0, see, when you are dealing with 50,000, 1 lakh or 2 crores, it will be taking a lot of time for processing. Now anywhere sometimes like even like 1% or 2% of the time such things happen where you are dividing by 0 or you are trying to take logarithm of a negative value. You do not want the entire thing to crash suddenly, right, and all that work would be wasted. So in such cases, when such things happens, then NaN would be automatically generated by pandas and substituted over there. You can also actually explicitly define on your own in your program an NaN value. Okay, so basically to indicate that you do not have a value there, you have a missing value. So that is also possible. So pandas also implicitly generates NaN values wherever some conditions like logarithm of negative values or some kind of exceptions or division by 0, something like that happens. And you as a programmer also, you can also put in NaN values to define that there is a missing value. So like this. So suppose when you're creating a series, right, and you do not have data, so in such case you can also specify NaN. How do you define NaN as? You just, because it's part of NP and this concept is already there in NumPy, you are reusing it in series as well. So you just write here np.nan. So what happens is you are indicating that there is a missing value in this field, and when it is executed, naturally the value will come as NaN over here. Okay, now upon this NaN also you can do some kind of operations, right? So in order to you want to find out whether there is a missing value or not. Suppose, right, you are having some 50,000 rows in your, you're working on some doing some statistical analysis, you have taken some data from valid place where there are 50,000 rows, and there are chances that lot of times NaN would be generated. Now you want to identify, right, where NaN values are there, So in such cases you have useful function called as isnull function. So what does a isnull function do is, if there is a NaN, it will return a boolean value saying true. And not null function just does the reverse, right? If there is a NaN value, it will return the value false. It just does the reverse. See this example here. I have created a series S2 where at this index 2 I have a NaN value. Now upon S2, if I call the isNull function, I say S2 dot isNull. So what happens? Is null. So it will check for each one. 5 is null? No. Therefore it will return a false. Minus 3 is null? No. So it returns a false. NaN is null? Yes. So it returns a true. 14 is null? No. So it returns a false. Similarly, when you use not null function, it does the reverse. You can see it's just giving a reverse. So basically isNull and not null function is very useful when you want to identify the indexes without a value. Okay, and you also have one more concept. So you can give this isNull and not null as a filtering. You can do filtering. You can filter out your series, right? So wherever there is not a null, that means let me say I have like 50,000 rows of data, right? And I just want to eliminate all those rows which have not null, right? Real time when you're working, you will be having lakhs of images, lakhs of data. So manually I cannot go and remove these rows. So I don't want to have NaN in my data which data set which I am having. So what do you do is just one single line of code, right? Just write this. You have the data. Let's say it is in S2, which is a series, and to that you just give this filtering mechanism. Say that not null, S2 dot null. So what does it do? In S2, wherever not null, wherever there is no null value, only that would be displayed. See, just by one single line I can filter out all those rows which are having NaN values, right? Very simple. Or I can do the reverse. I can just have NaN values also. For that, what you have to do, if you just want to display all the rows which are having NaN, then just give S2 dot isNull. So it's a very useful function. I say this is very useful because this is a very common problem that we see in real time. When you start doing projects, you will understand. So this is a very useful concept. If you want to get rid of the NaNs from your data set, just use this. You say from your series, give the filtering function S2 dot null. Or if you just want to see which all rows are having NaN, just give S2 dot isNull. See what has happened here. S2 is having null at which point? In the second row, right? See, and that has been eliminated here. Second row has been eliminated, but in the other one only that second row is displayed. So it's a very useful concept, NaN. So we have learned now what is NaN, how pandas will implicitly add NaN whenever there's a missing value. We can also specify our own NaN. We have seen how to use this not null and isNull function to display only the rows with NaN values, or to display the rows which are not having NaN values. Very useful concept. So to quickly revise, in today's session we saw the filtering mechanism. See, this is the same filtering mechanism that we used at the end for NaN, right? So we filtered out in our series only the rows which are having NaN, and we also filtered out only the rows which are not having NaN. So that's how filtering is very useful concept. And we can do a lot of mathematical operations on our series. You can do scalar operations. You can also add and multiply or divide between the series. You can do a lot of evaluations, like within our series you can find unique values. You can also count how many times a particular value is occurring. You also have isin function. You can find out whether a particular value is present or not using isin or function. And we saw how the importance of NaN values and how we can use it, how we can filter out the rows with NaN using the NaN values concept. So in the next session we will be going deeper again into the next Pandas series concept. We will see how we can do operations between the series, and we will also see series as dictionaries. Thank you.